So today we're going to look at a related rates problem with a cone. So it says a conical cup is 6 inches across and 6 inches deep. Water leaks out of the bottom at a rate of 2 inches cubed per second. How fast is the water level dropping when the height of the water is 2 inches? Okay, so let's kind of draw this out and list some information here. So we have this conical cup here, and it's 6 inches across, and it's also 6 inches deep. Okay, so we know the height there is going to be 6 inches as well. So in that case, that gives us the information that the diameter is 6 inches, and the current height is also 6 inches. Okay, then we have a few other pieces of information here. It says water leaks out of the bottom at a rate of 2 cubic inches per second. Now there's a built-in hint to this, and the hint is that our units here are cubed. So that's going to tell you that this is actually the change in volume. So that's our dV dt in this case. And since the water level is leaking, we're losing it or subtracting 2 out. Inches cubed per second here. That's why it's going to be negative. All right. And then we also need to know, okay, well, what the formula for volume of a cone is. In this case, the volume of a cone is that 1/3 pi r squared h. All right, so as you can see here, we need to know what the radius is in order to be able to do this. So if they give us the diameter 6, that means that our radius here would be 3 inches. We should also write what we're looking for. It says, how fast is the water level dropping? Okay, so we want to know what the height is changing, or how the height is changing here. So that would be our dH dt. That's what we're looking for. Okay. All right, now we also don't want 2 different variables in this. We want to bring it down to a single variable here. So we need to figure out what a relationship is between the radius and the height. Well, as you can see, the height is double the radius. So in this case, h equals 2r. But since we're looking for dH dt, I want everything in terms of h. So I'm going to simply solve for r here by dividing by 2. And I'm going to get that the radius is h over 2. Now I'm going to take that and go ahead and substitute that into my formula here for r. So we get that the volume is 1/3 pi h over 2 squared times h. And then we're going to go ahead and simplify this down here. So we'll get that the volume is equal to 1/3 pi, and then if we square that whole thing, that becomes h squared over 2 squared, which is 4, times h. And then simplifying that all down together, we'll get that the volume is, let's combine the 3 and the 4 here. 3 times 4, that gives us 1/12 pi, and then h squared times h is h to the 3rd. Okay, so here's our formula. Now, since we're trying to find dH dt, we're going to go ahead and take the derivative of this. And if we take the derivative, we'll simply get that dV dt is equal to, and we're going to bring the 3 down in front, 3/12 pi h squared times dH dt. And 3/12 simply reduces down to 1/4. Okay, now we can substitute in the information that we knew from above. So let me just fit this all in here. So dV dt, we knew that was -2. Then we have the 1/4 pi. And now we wanted to know this when the height was 2 inches. So when h is 2. So when h equals 2. So this is going to be the value for the height that we substitute into our equation here for h. So we're going to put in 2 squared times dH dt. And now we can go ahead and finish solving this out. So we'll get that is -2 equals 1/4 pi 2 squared becomes 4 dH dt. Simplify this down. 4 over 4 will reduce to 1. And then lastly here we'll end up with, I'll write it out, -2 equals pi times dH dt. Simply divide by that pi, divide by pi, and we get dH dt, or the change in height, is going to be -2 over pi inches per second. And that would be the answer to this problem. All right, hope that helps. If you have further questions, feel free to leave your questions in the comments below, and I'll try to answer them when I get around to it. All right, have a good one.